Alright guys, today's goal, the learner will understand probabilities. We're going to be looking at sample spaces and probability functions, determining probabilities, Venn diagrams and tree diagrams, conditional probabilities, and binomial distributions. And why? Everyone should know how mathematical the laws of chance really are. So let's take a look at an example here. If E is an event in a finite, non-empty sample space of S of equally likely outcomes, then the probability of E is the number of outcomes in E divided by the number of outcomes in S, meaning the total sample space. Okay? So it's success divided by the total. That's another way of thinking about that. So here we go. Outcome. So here's your probabilities. This is rolling 2 dice, rolling a combination of 2, so 1 and 1, total of 2 is 1 out of 36, because the only way you can do that is roll a 1 and a 1. So these are all the ways, these are all the probabilities that we can use here. So let's take a look at our problem. It says, find the probability of rolling a sum divisible by 4 on a single roll of 2 fair dice. Okay, so let's see, divisible by 4. Which ones are divisible by 4? A total of 4, 8, 12. So what you need to do is take these totals take a look at these totals and then we add them together. So you have a total of 3 over 36 plus 5 over 36 plus 1 over 36. There's 9 total chances of being successful divided by 36 total outcomes. Well, hold on. Not done yet. So 1/4 or 0.25. Okay? So there's the probabilities. Alright. A probability function is a function P that assigns a real number to each outcome in a sample space S subject to the following conditions. It's got to be greater than or equal to a probability of 0 and less than 1, because bigger than 1 is over 100% chance of happening, and that's not possible. The sum of the probabilities of all the outcomes is 1, meaning if you add up all the possible outcomes, it equals 100% chance. And the probability of the whole set not occurring is 0. Okay? It says, let S be a finite non-empty sample space in which every outcome has a probability assigned to it by probability function P. If E is any event S, the probability of E is the sum of the probabilities of all the outcomes contained in E. That's like what it's showing you up there when it's finite, just like what we did. So let's take a look at some different examples. Okay, determine the sample space of all possible outcomes. When possible, choose outcomes that are equally likely. If the sample space has equally likely outcomes, the probability of an event E is determined by counting principle. So that's what we just did, the number divided by the total. If the sample space does not have equally like count, determine the probability function. This is not always easy to do. Check to be sure that the conditions of a probability function are satisfied. Then the probability of event E is determined by adding up the probabilities of all the outcomes contained in E. Okay? So that's just different ways of looking at it. Alright, so let's take a look at this. Alright, so it says Dylan opens a box of dozen chocolate creams and offers 3 of them to Russell. Russell likes vanilla creams the best, but all the chocolates look alike on the outside. If the 5 of the 12 creams are vanilla, what is the probability that all of Russell's picks are vanilla? All right, so there's a couple different ways we could look at it. Here's one using our combinations we talked about. There are 12. We are choosing 3 of them. That equals 220. So there's 220 total ways of picking these different ones. Okay? Now, we want to choose the vanilla. So we need to look. There are 5 vanilla. We are choosing 3 because we need to get how many ways are there doing that. That is 10. All right, so now we have a total of probability chance of success is 10. The total is 220. So it's 1/22. Okay? So there's one way. Now another way is just thinking about it. You go into the bag. What's the probability you're going to get the first one to be a vanilla? 5 out of 12. You get a vanilla. You go to pick another one. Well, there's only 4 vanilla left, and there's 11 total. Another one. Now there's 3 vanilla left, and there's 11 total, or 10 total. So multiply these out. Well, simplify this first. You get 1/22. So either way of calculating the probabilities there. Okay? So let's take a look at another example. So suppose event A has a probability of P1 and event B has a probability of P2 under the assumption that A occurs. Then the probability of both A and B is the probability of 1 times the probability of 2. That's how we got that second way of doing that. Okay? Alright, so here's another example. It says, suppose Tommy makes 92% of his free throws. If he shoots 15 free throws, and if his chance of making each one is independent to the other shots, what is the probability he makes exactly 10? Alright, so first thing we need to do is we need to figure out how many ways could this occur. So order doesn't matter, so it's 15, choose 10. And then how many successes? What's our probability of success? 92%. We're doing it 10 times. And then you have an 8% chance of missing. Well, how many would we miss if he made it exactly 10? 5. Calculate that out in your calculator, and it would be approximately 0.04. Oh, I missed a 0 there. So there's the probability of that happening, okay? If you're not sure, we'll talk about that more in class, but so let's take a look at our last definition here. All right, if event B depends on event A, then the probability of B given A, that's what this symbol means, it's B given A happens, is the probability of A and B happening divided by the probability of A. Okay. Suppose we have drawn a cookie jar at random from one of the 2 identical, or a cookie at random from one of the 2 identical cookie jars. Jar A contains 3 chocolate chip and 2 peanut butter, while jar B contains 2 chocolate chip. Given that it is a chocolate chip cookie, what is the probability that came from jar A? So we're given that it's the chocolate chip cookie, and we want to find out the probability that came from jar A. So I like to draw pictures here. Here's jar A. Here's jar B. Don't you have a 50% chance there? Now jar A. 1, 2, 3. Chocolate chip, chocolate chip, chocolate chip. Peanut butter, peanut butter. Chocolate chip, chocolate chip. So we need to figure out the probability of A and B occurring. So chocolate chip from jar A. So if you think about this, jar A, you have a 50% chance, and then when you're in jar A, you have a 20% chance of each cookie happening. But the probability you came from A and B, that means multiply. So 0.5 times 0.2 is 0.1. So each one of these cookies has a 10% chance of happening. So we know the top, well, there's 3 of those possibilities happening, so you have 0.3. That's what the probability of A and B is. Now you have to find the probability of A. Well, what's the probability? Doesn't matter which chart. What's the probability that you got a chocolate chip cookie? Well, there's 1, 2, 3, 4, 5. There's 5 different chocolate chip cookies, but for this cookie jar, it doesn't matter. So there's a 50% chance if you chose that you'd get a chocolate chip cookie. 50% plus the 30% from jar A. So you have 0.3 divided by 0.8, which is 3/8. That's your probability that you got a chocolate chip cookie, and it came from jar A. Okay? See you guys tomorrow.